Imagine if the most important image ever taken in human history hadn't come from the Hubble, the James Webb Space Telescope, or even Perseverance on Mars, but rather from a spacecraft launched more than 40 years ago. The spacecraft is now more than 14 billion miles from Earth and has returned an incredibly unexpected photograph from the outermost reaches of our solar system. The image comes from a spacecraft launched in 1977, which is believed to be long past its imaging prime, but this single frame is captivating scientists and astronomers worldwide, sparking discussions and new theories at the very edge of known space. In March 2025, NASA's Jet Propulsion Laboratory quietly released a new image captured as Voyager passed through the heliport, the boundary where the sun's solar wind gives way to interstellar space. At first glance, the image appeared to show nothing more than static scattered green and purple pixels against a black backdrop, but scientists were able to denice and reconstruct the image using new machine learning algorithms trained on data from missions like Cassini at Saturn and New Horizons at Pluto. This unexpected image was taken by Voyager 1's imaging science subsystem, a system of narrow-angle and wide-angle cameras that were never intended for deep space astrophotography at such an immense distance. Nothing like this was visible when Voyager 1 last captured this region in 2012, but what emerged astounded them was a vast filament-like structure that stretched the frame like glowing strands of plasma stretching through the dimming solar boundary. This was not just another pale blue dot, but something completely different, an enormous luminous network that seemed to trace invisible magnetic field lines or possibly interstellar dust flows entering our solar system. Additionally, the spacecraft's sensors identified irregular plasma wave activity and cosmic ray flow, which were strongly connected with variations in the picture brightness. This implied that what we are seeing is a snapshot of dynamic processes taking place at the interface between the vast interstellar medium and our solar system rather than anything static. The expedition of Voyager 1 started in 1977. Originally assigned to explore the outer planets, Voyager far exceeded expectations by delivering crucial data from Titan, Saturn, Uranus, and Neptune. After passing beyond Neptune, it continued toward the edge of the Sun's influence and officially entered interstellar space in August 2012. Since then, its scientific payload, which included its cosmic ray sensors, magnetometer, and plasma detectors, has remained active even though its cameras were mostly dormant to conserve power. More recently, NASA engineers were able to update its flight software, reawakening its imaging system for one last ultra-long exposure. The final image was stitched together using custom algorithms developed at JPL. The outcome was both a technological marvel and a visual surprise, offering the first optical view of the heliport that conventional photography could not capture. The ramifications are extensive, and experts are now trying to decipher what the picture depicts. There are now three main theories. Dr. Leila Moreno, a plasma physicist at the University of Chicago, hypothesizes that the structures could be filamentary plasma formations brought about by the interweaving of the sun's magnetic field lines, which could cause charged particles moving along these lines to emit the faint glow visible in the picture. The most speculative theory comes from theoretical astrophysicist Dr. Amara Oe of Ghana, who suggests that the image might be showing evidence of Axie-like dark matter particles converting into photons under the influence of strong magnetic fields, a process the heliport may naturally support. This would make Voyager 1's image a rare, possibly groundbreaking piece of indirect evidence for dark matter, but these theories are still theoretical. A second theory, led by Dr. Caspar Vogel at Cornell, suggests that electrically charged interstellar dust grains are colliding with solar wind particles as they cross into the heliport, producing faint light only visible through long-duration imaging. The scientific community is treating this discovery seriously, as evidenced by the peer-reviewed papers that have already been published in prestigious journals like Nature Astronomy and Physical Review Letters. However, what really unravels the mystery is what researchers discovered next: a faint but statistically significant hexagonal pattern embedded within the plasma filaments. This honeycomb-like lattice isn't just visual noise. All three are based on sound physics and supported by Voyager's onboard measurements. The idea of a giant hexagonal pattern at the heliport is unprecedented, but hexagonal structures like the one at Saturn's North Pole have been observed. The hexagon's alignment with Voyager's spin axis and not with known magnetic geometries suggests that it may be either a data artifact or, more intriguingly, a real spatial structure formed by alternating magnetic domains. Could these be magnetic reconnection islands, or are we witnessing a type of plasma instability never before documented? This oddity is perplexing scientists and igniting late-night debates in laboratories and observatories worldwide, but the tale doesn't stop there. Nothing of this magnitude or in this area has ever been suggested. A group of ESA specialists in low-light photography from the New Horizon mission processed the raw data using their sophisticated quantum-aided enhancement methods shortly after NASA published Voyager's denoised picture. Even more shocking was the discovery of a second filament that was wider and fainter than the first, tilted precisely 60 degrees in relation. This wasn't a mistake or lens artifact. Rather, it was a genuine structure. The ESA team observed a remarkable symmetry when they superimposed both filaments in a 3D model of Voyager's field of view. 12 radial lines that resembled wheel spokes developed from the design. The whole structure revolved over the picture field like the dial of a cosmic clock, with one set being brilliant and narrow and the other broad and ghostly, stacked like harmonics in a sound wave. The angular accuracy was too reliable to be written off as a coincidence. Researchers speculated that this may be proof of a magnetohydrodynamic resonance, an oscillation at the solar-interstellar plasma interface. According to one scientist, we've only just started to hear the pulse of our solar system's periphery. Nothing like this was expected by any of our current models. The existence of the structures was not predicted by the Parker spiral outer helio sheath models or even by Voyager's particle pressure trajectory estimates. This finding marks a significant turning point for planetary science and astrophysics as it raises the possibility that the solar boundary zone is much more intricate, possibly even stacked in a higher dimensional structure than previously thought. In an era of distraction and division, Voyager's image reawakens something profoundly human wonder. This silent ancient spacecraft has given us a gift of a deeper perspective. We now have direct visual evidence of processes occurring where the sun's influence wanes and the galaxy begins. These are not just data points. They are visual records of large-scale plasma and magnetic field interactions that may reveal new physics beyond the standard model for the public. The Voyager mission reminds us that our solar system doesn't simply end. It transitions, interacts, vibrates, and, now that we know it may even echo through plasma filaments, hexagonal patterns, and the spokes of a vast magnetic wheel, it transmits at 23 watts less power than a nightlight and has 68 kilobits of memory. What this image represents goes beyond visual beauty. Sometimes the biggest revelations come from old data reanalyzed with new tools from the patience to look again and the willingness to question what we thought we understood. If such structures exist here, could they exist elsewhere as well? Could each star system have its own echo, boundary pattern, and heartbeat? More intriguingly, could these structures encode information in the form of rhythms and geometries that allude to deeper physical laws rather than alien messages? After all, the cosmos is made up of information as well as energy and matter, and maybe the feeble signal from Voyager is giving us the first hint of that deeper reality. Its new image from the very edge of our solar system has challenged preconceptions and rekindled interest across the sciences, reminding us that exploration never stops and that sometimes the faintest signals carry the most profound messages. Voyager 1 is more than just a relic. It is a messenger,